So today we're discussing the angles of triangles. So we're going to start out with our vocabulary and some postulates and theorems and even some corollaries today. So vocabulary, we have exterior angle. An exterior angle is formed by one side of a triangle and the extension of another side. So if you look down here at the picture, we have one side of the triangle here and the extension of this other side. It's being extended out, and that forms our exterior angle. The next one is a remote interior angles. The interior angles of the triangle not adjacent. So if you remember, adjacent means it's right next to it. So if we look here at our exterior, the adjacent would be right inside here. So it's the ones that are not adjacent to that given exterior angle. Those are called the remote interior angles. So that would be these two angles over here are our remote interior angles. Okay? Now we're going to start looking at some theorems. So slide up here. So our first theorem, we have the angle sum theorem. The sum of the measure of the angles of a triangle is 180 degrees. So anytime we add up the three angles inside of our triangle, we're always going to get 180 degrees. So if we add the measure, this m is the measure of angle W plus the measure of angle X plus the measure of angle Y is going to give us 180 degrees. I'll go ahead and put my little degrees symbol on those. Then the next theorem that we have is the third angle theorem. That theorem tells us that if we have two triangles here, if we have two of the angles are congruent to two of the angles on the other triangle, then we know that the third angle also has to be congruent. So we have our triangle here, ABC, and we have FED. So if angle A is congruent to angle F, and angle C is congruent to angle D, then we know that B has to be congruent to E. And that's all that's telling us. So we have two angles on one triangle, two angles on the other triangle, they're congruent to one another, so then the third angle on those triangles also has to be congruent. Okay? We've got another theorem here. Our last theorem is the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interiors. So what that's saying is this exterior angle here, angle YZP, is equal to our angle X and Y when we add them together. So it's equal to the sum of measures of angle X and the measure of angle Y. Okay? So that's all for the theorems. I do have a couple corollaries. So this is the first time we're seeing corollaries. What a corollary is it's just a statement that can be easily proved using one of our theorems. So we do have two corollaries. The first one says that the acute angles of a right triangle are complementary. And we know that because we said earlier our triangle sum theorem told us that when we add the three up, we should get 180 degrees. Well, if we already know one is 90, how much is left? 90 degrees. So these two, G and J, have to add up to equal 90. Okay, and then the other corollary says that there can be at most one right or obtuse angle in a triangle. Well, we know we can't have more than that because if we had two right angles, that's 180 degrees right there. So we don't have anything for the third. So that doesn't make a triangle. Okay, so that's like this one here. And if we have an obtuse angle, then obviously these have to be acute because again, they have to add up to a total of 180. If this is already 142, you can't have another obtuse or right angle in there. Okay? So let's look at some examples then. Here's our first example. So we have this nice picture over here. So you can go ahead and write that picture down. We're going to use it for three different angles. So we're going to be finding the measure of each of those angles. So we look here, we're going to be doing angle 1, angle 2, and angle 3. So let's just start with the measure of angle 1. So what do we know about angle 1? Well, it looks to me like angle 1 is an exterior angle. So when I look back, we know that our remote interior angles, where do we have, sorry here, our remote interior angles are equal to this exterior angle. Okay, the interior angles of the triangle not adjacent to the given exterior angle are called remote interior angles. We also know that these are equal to each other. If you remember, that was this one. So we know if we add those together, they are equal. So if we add these two together, so we have 23 plus 32, those are our two remotes. This is our exterior, equals the measure of angle 1. So we add together the two remotes, that gives us the exterior. So if we add these together, we should get 55 equals the measure of angle 1. Hang on just a second there, I'm going to grab a different pen. Mine seems to be running out. Okay, so let's see if we can, there it goes, the measure of angle 1. Alright, so then we're going to go on, I'm going to go ahead and label here, so this is 55 degrees because that's going to help me later. So then I know for angle 2 is an interior. Now in relation to angle 1, again, this would be considered a remote interior. So if I add these two together, I should get my exterior again. That's the exact same theorem and definitions that we looked at for number 1. So I have 22, which is down here, that's this one, plus the measure of angle 2 equals 55. So then to solve for the measure of angle 2 here, I'm going to subtract 22 from both sides. So I get the measure of angle 2 equals 33. Okay, so this is 33 in here. Now to do number 3. Number 3 is just a little bit different. So number 3 is also an exterior, but 2 would be adjacent to it. So we can approach this a couple different ways. One, we could figure out this other angle in here, and then we could use our two remotes to find our exterior. The other thing that we can do is we know that this is a straight line. That's extending the side. So a straight line always adds up to 180 degrees. So if I add the measure of angle 2 plus the measure of angle 3, I should get 180 degrees. Okay, now I already know, I already know that the measure of angle 2 is 33, so I'm going to put that in. So 33 plus the measure of angle 3 equals 180. Then I'm going to subtract 33 so that I get the measure of angle 3 by itself. The measure of angle 3 I subtract here. Well, I can't subtract anything from 0, so I have to borrow. So I've got 7, 4, and 1. So the measure of angle 3 is 147. And if I add those back together, I should get 180, which is a straight line or a straight angle. Okay? All right, let's look at some more examples. So we have another picture here. So on this picture, we're going to again find the measures of our angles. We have 1, 2, and 3. So here's the measure of angle 1, 2, and then 3 is down here in this corner. All right, so let's start with angle 1. Well, we know from one of our theorems, we have our angle sum theorem that tells us that if we add up all three angles, we should get 180. We have 2, so we're looking for the third interior angle. So we're going to take 47 plus 57 plus the measure of angle 1 equals 180. So we're going to add these two together. So 47 plus 57, we get 14, carry our 1, we get 10. So we have 104 plus the measure of angle 1 equals 180. So we're going to subtract the 104 from both sides. So we end up with the measure of angle 1 equals 76. So I'm going to write my 76 in here. Okay, we can even write it up here. So 76 degrees. Now looking at angle 1 and angle 2, what do we know about the relationship to those? This is something we talked about in the first quarter. Angle 1 and angle 2 are vertical angles. So we know that the measure of angle 1 equals the measure of angle 2 because they are vertical. So if the measure of angle 1 is 76, then the measure of angle 2 is going to be 76. Okay, so I'm going to go ahead and write 76 in here as well. Now we're looking at angle 3. Well, angle 3 is also an interior. We have two of them. We need the third, so just like we did before, we're going to be adding these two together, plus the third will give us 180. So we have 76 plus 55 plus the measure of angle 3 equals 180 degrees. So then when we add these together, 6 plus 5 is 11, carry our 1. We've got 8, 9, 10, 11, 12, 13 plus the measure of angle 3 equals 180. So subtracting the 131 from both sides, we end up with the measure of angle 3 equals, again we can't subtract from 0, so we have to borrow, so we end up with 9, can't count today, 9, 8 minus 3, or excuse me, 7 minus 3, 7, 6, 5, 4. I'm really having trouble counting today. So we have 49. 1 minus 1 is your 0. So the measure of angle 3 is 49 degrees. Okay? Alright, great job with those, even if I can't count. Let's go on to a few more examples. Okay, so we have another picture here. So with this picture, we're going to be finding the measures of angle 1, 2, 3, and 4. So I'll have to slide down when we get to 4. So we know that the measure of angle DGF equals 53. So DGF, so I'm going to label this as 53. They told us that. And then they also said that AGC is 40. So AGC, we know this one is 40. And we're going to use that information to be able to find the other angles. So we're going to start with angle 1 again. With angle 1, we have a 90-degree angle here. That's that little symbol, tells us that's 90. We have a 53, and angle 1 is our other interior. So we can add those three up. Remember, that's our interior angle sum theorem. So we have 53 plus 90 plus the measure of angle 1 equals 180 degrees. So we're going to add these two together first. So we get 143 plus the measure of angle 1 equals 180. Subtract the 143 from both sides, and we end up with the measure of angle 1 equals, so we're going to be subtracting here. We can't subtract anything from 0, so we borrow. Hopefully I can do this one a little bit better. Here's 10, so we have 7. 7 minus 4 is 3, and then our 0, so we have 37 degrees there. So this one equals 37, and we'll write it in here. Okay. So then the next one is angle 2. Well, when I'm looking at angle 2, I don't know anything. I know this is a right angle, but I don't know anything about 4. So I can't do my interior angle sum theorem. I also know that this here is a right angle. When I add this angle to angle 2, I should get 90 degrees, so I'm going to use that. So the measure of angle 2 plus 40 equals 90. So just subtracting 40 from both sides. So the measure of angle 2 equals 50. So I'm going to put 50 in here. Now that I know that, I'm going to come over here to 3. So I have a 40, I have a 90, and a 3. These are all interior angles again. So I'm just going to add those together. So we're going to go the measure of angle 3 plus 40 plus 90 equals 180. So adding these two together, I get 130. And the measure of angle 3 plus that equals 180. So subtracting the 130, I end up with the measure of angle 3 equals 50. 50 degrees there. We could also have used our corollary that says if you have a right triangle, then your other two are going to be complementary, so they're going to equal 90. We could have also used that there as well. I'm going to use that here for number 4. Okay, so just another way of finding it, instead of using our interior angle sum theorem, we're actually going to use that corollary. If you remember this corollary over here, 4:1, the acute angles of a right triangle are complementary. So we're going to use that one for number 4. So we have for number 4 up here, we have the two acutes to a right triangle should be complementary. So we have a 50 and angle 4. So I'm going to have 50 plus the measure of angle 4 equals 90 since they are complementary. So then subtracting 50, the measure of angle 4 equals 40. So I'm going to come back up here, and this is 40 degrees, and then I'll write it down here as well. The measure of angle 4 equals 40 degrees, and this one was 50. Okay, so then we have all of those. We did them a couple different ways. We had the interior angle sum theorem. We also had complementary because they were right angles, and then we had the corollary that says our acute angles to a right triangle are complementary. Okay, that is the last one that I have for today. Have a great day, and I'll see you in class tomorrow.